looks like we're live. Close that. All right. Hey guys, welcome back to our continuation from last time for this week's live stream. We are going over the build process, start to finish, from land to a finished product that you can put on the market. What's that complete process look like? I've broken it down into some basic steps. We can go back over that real quick as an overview, and then we'll jump back into where we left off last time. Last time we got up to the foundation, talked about some foundation stuff. So today we're going to start off with the overview, then we'll move on to sub slab, which is our fourth step out of the steps that I have here. And then we'll continue from there for as long as we can. So as always, let me know if you have any questions. I do have the chat open. Let me check and make sure. Yeah. So I'm happy to answer any questions along the way. This is really for your guys' benefit. I do want to say, just get this out there. This is not very high quality video. I understand that. I'm doing live streams here, just trying to get this information out there to begin with, get some questions from people watching these streams. So leave questions in the comments if you're watching this later on. I will be putting together some better quality, edited videos that covers all of this stuff down the road. But for now, it's easier for me to get all this information out there quickly by doing live streams. And as I said, I like getting questions from people because that helps me kind of identify areas that I need to focus on more. So with that said, let's go over kind of the overview of what we have. So the home building process starts off with planning. Okay, this is probably the most important step of the entire process because this determines how well everything else flows. So planning, hugely important. That's step one. Step two, you have excavation. This is where you're going to dig whatever you need to dig, do your grading, all that clearing, those sort of things. Step three is your foundation. This is where we left off last time. We discussed this. And then, so foundation, you have a lot of different options. Mostly poured concrete is going to take a role in some form or another. There are some options otherwise, but if you're building houses for money, I highly recommend you just go with poured concrete, or block is an option if you have good labor for it in your area. I don't really know of anybody that does good block work in my area, but there are some really good contractors for poured concrete, so I typically just go poured concrete. There are some other options. Precast is something that's gaining a little more popularity these days. But anyway, so that's step three, your foundation. Step four, this is what we'll start our conversation off with today, as soon as we finish this overview. So step four is going to be your sub slabs. This covers your drain waste vent, so DWV for your plumbing, anything that's below slab. If you have a slab, if you're doing crawl space, there's not a whole lot here. You still have to worry about drainage, radon. So those are two more things. You want to make sure you have proper gravel and vapor barrier. If you're doing crawl space, vapor barrier is very important. On the bottom, on the ground. Okay. And then, and then you'll have your radon vent that vents up from there. So that's all what I would consider sub slab. For basements and slab foundations, you're also going to have insulation. Typically these days, that's pretty standard. If you're not doing it, I would highly recommend you look into it. Insulation is good to have under slabs. Nowadays, I would do a minimum of 2-inch foam board. You can also do spray foam. I've seen some interesting stuff. I know a lot of people out there don't like closed cell spray foam these days for various reasons. But that's also an option. I've seen people do that under slab. If you have a good contractor for it, they can get a nice even coat across the whole floor before you pour your slab. That also works great. So those are the basics of all your sub slab for step four. Step five, you're moving into framing. Okay, this is where you gotta frame the house. This is probably the biggest step out of all of it. Your foundation would be the next biggest, but framing is really the biggest if you include your sheathing and all that with it. So this is gonna be the biggest chunk of your budget, biggest chunk of your time, and you really can't stop in the middle of it. Once you start framing, you need to get it dried in as quickly as you can. So it's kind of, that's the go minute, and then you can take a breath once you're finished with that. With framing, there's a couple main things that we'll discuss. The main things are going to be materials and equipment, and then labor. Those are your three main components when it comes to framing. So we'll discuss that in more detail today as well. Step 6, So that was step 5, framing. Step 6, you're going into sheathing. I set this as a separate step. Oftentimes this is taken care of along with the framing. Okay, this is done as soon as you're done framing. Your framers are going to do the sheathing as well, if not while they're framing. Okay, there's different methods to building walls on a house. But basically these 2 steps are going to be done in tandem. I separate them out into separate steps though, because they generally do require separate inspections. Okay, now each one of these steps typically just has 1 inspection with it. I try to split 1 inspection per step, unless you have some special inspections. Okay, that's always a possibility depending on what your build specifics are. But generally speaking, you're going to have 1 inspection at the end of each one of these steps, or close to the end. In the case of foundation, you're getting the inspection before you pour the concrete. So framing, then you'll have sheathing. Sheathing, this basically gets your roof on, right? This is your roofing deck. This is going to be your shear walls around all of your walls on the outside, typically, as well as possibly some on the interior, depending on your layout. So very important that structurally, that's a very important part. So sheathing, you'll have an inspection at the end of sheathing. They're going to come out, look at your nails, look at your sheathing thickness, make sure it matches plans. Make sure you got the gap in between sheets, all that sort of stuff. So step 6 is sheathing. Step 7 is going to be your dry in. This is where you're getting everything waterproofed, more or less. It's really water resistant, but whatever. So this is gonna be like your house wrap going on, or if you're using zip system, getting it all taped up and everything. This is gonna be your roof underlayment. This is gonna be ice and water for the roof as well, ice and water shield. What else goes with dry-in? Your flashing for like windows and stuff, getting windows put in is a big part of that. Doors too. Temporary doors, use temporary doors if during construction, and then switch it like the front door if you got traffic going in and out. A lot of times a door to the garage gets used a lot during construction, so things like that. But basically drying it in the house gets everything sealed up so that it can rain, snow, pour, high wind, whatever, and the interior of the house is going to be safe, and that allows you to move on to the next few steps. Also with dry-in comes roof, but I have that separated out as step 8 because, again, the inspections. Step 7, the dry-in inspection, you need all that inspected. Your roof underlayment and ice and water shield needs to be inspected before you move on to your roofing and put your final roofing on. So roofing is step 8. There's not a whole lot to cover with roofing. Really, it just comes down to material choice. But we'll hopefully get to that today as well. Step 9, mechanical rough-ins. Okay, basically from this point on, we're doing rough-ins for the next few steps. You typically want your rough-ins to take place in order from largest to smallest. Okay, so your ducting for mechanical is going to be your largest. Then your plumbing is going to be a little bit smaller in physical size, right? The pipes are a little bit smaller than ducting. So that's your next, and then electrical wiring, all your electrical rough-in will be last because that's the small. So those are your 3 rough-ins, MEP, mechanical, electrical, and plumbing. So mechanical first, a few different things with that. You got, like your HVAC system, whatever you're using for heating and cooling. You got ERVs, dehumidifiers, you got your vents for like dryer vent, you got bathroom exhaust vents, all those kind of things. So that's step 9, mechanical rough-in. Step 10, plumbing rough-in. This is going to finish all of your drain lines throughout the whole house, your water lines through the whole house. Today, that's mostly always done in PEX. If you're doing something high-end, I still see some copper, but mostly PEX these days. So it's very simple, very quick. I do a lot of that myself, actually, and I'm by no means a plumber. What else? Gas will also, if you have any gas lines coming into the house, that's typically done at plumbing as well. And then your electrical, plumbing. One more thing with plumbing rough-in, make sure you're doing your radon vent up through the house. It needs to go from your foundation, like I was talking about earlier, the radon vent is going to go all the way through the house to the roof and vent out the roof. So at this point, the plumber will just finish that going straight up to the roof. Electrical rough-in. This is going to have your panel, receptacle boxes are going to be put in, fixture boxes, all your wiring is going to get put in. And so you'll just have wire going all throughout the house. All the wire will just terminate at the boxes. You're not going to have any switches or plugs or anything in there yet, unless you need some for temporary use or use during construction. But basically this is just your electrical rough-in. So all the wiring gets put in and then your panel is getting put in. And then you may run one circuit just for use during construction typically. So that covers your MEP rough-ins. All of these typically will be inspected, but you can usually get them all inspected at the same time, one inspection for all of them. It's your rough-in inspection. You can usually also have your framing inspection and sheathing inspection done at the same time as well, as long as all the sheathing is still exposed. If you're going to be covering up with underlayment or whatever, house wrap, go ahead and have your inspector come out and look at the sheathing even before you're done with framing or anything else. That's fine. But then when you have your framing done, get your rough-ins done. Hopefully none of your framing's getting covered up or anything. It's really good. Most inspectors want to see framing with the rough-ins in there, so they can make sure that none of the load-bearing members of the walls or anything are getting hacked to pieces by your subs, right? But they will be looking at that as well when they come back to do your inspections for your MEP anyways. So you'll have all your rough-in inspection done at that point for MEP, framing, all that. If you pass all your inspections, now you're past step 9 mechanical, 10 plumbing, and 11 electrical. You're moving on to step 12. That's going to be installation. Okay, this is when you're starting to cover everything up. So you got to make sure your inspections are good. Take some video, photos, whatever, of all your walls before you start covering everything up with insulation and then drywall. So installation, step 12. Basically, this is very simple. Just you have a few different options and materials, and you have code that determines what your minimum R values are. At least meet your minimum R values. Go above it if you like to. There's different studies that show different return on value for certain R values. It's up to you. I typically just stick with what's code required in my area. One exception to that right now, I prefer, if I can, to build my roofs with my lid with an R60, because that is current code, the latest version of code. In my area, we're still on 2018 IRC code. And when they created the ordinance back then, they identified R49 as our lid requirement. So we're still requiring R49, but technically R60 would be the most up-to-date code and make the most sense for our climate zone. So I do try to go R60. Walls are R21 for my area. R19 is also, no, but I'm in a very cold climate zone. So we actually require minimum R21, which does fit in a 2x6 wall assembly. So as far as materials, you got, like, you can go with mineral wool, you can go with your typical fiberglass bats, you can go with spray foam, you can go with cellulose blown in, all these different options. We'll talk about that more when we get into installation, but that is step 12. After that, we get into step 13. This is your drywall phase. So get your installation inspected. When all that's done, make sure you foam around the windows, doors, your fire foam, and everything. We'll talk about that more, but once you have all that done, you pass inspection on your installation, you're covering it up with drywall. So get your drywall guys in there. Nowadays, I see a lot of guys just do 5/8 for the whole house. You technically only need 1/2 inch for most of a home. Ceilings, 5/8 is really good for ceilings, just because you'll have less issues with it. Trying to think if there's anything else major. We'll go into more detail with drywall when we get to that, but that's step 13. This is when the house really starts to look like a house on the interior, because the only step that's left after this point is step 14. That's your finish work. So this is where you're coming in, you're doing like siding, if you haven't done that yet, although usually that's being done while you're doing the interior work. But make sure your siding gets done. Then inside you're gonna have all your fixtures, trim, flooring, doors, all your interior doors are gonna go in. What else? Any exterior concrete work, like a little sidewalk path or driveways. Often I'll do driveways at this point and just use gravel up until that point. Yeah, stuff like that, landscaping. That's all going to be your finish work at the very end, and this is your last step. I include it all as one step. It's a big step because there's actually a whole lot that goes into that. So that gets broken down into some sub steps. Excuse me. But anyways, so we'll have a lot. I'll probably try and do just the finish step as one whole live stream. We may get to that 2 weeks from now. We'll see how far we get today. So that gives you, again, just to go back and cover the entire outline, the overview outline of the process again, for you guys. Now, At this point, we're going to move into picking up where we left off last time. So last time we talked about doing your planning, your excavation, and your foundation. Today we're going to talk about all your sub-slab stuff. So real quick, something I do get questions on quite a bit would be radon mitigation. Some parts of the country, this is not an issue. When I was down in Texas, I never even had heard of this. I moved up to the mountains, and it's a much bigger problem in the mountains. Anywhere where you got a lot of rock, granite, and stuff in the soil, I believe. So, these are radon mitigation. These are active radon mitigation systems here. Let me make sure. Yeah, you guys can see all that. Okay, right? Whatever. So, these are what you would put in if you're having issues in your house with radon. But nowadays, with new construction, most areas where radon is a concern are going to require, at a minimum, a passive radon system be put in. So let me see if I can pull up an example of that, because, and there's it's actually not even that long. Let me put in passive. Actually, this looks pretty good. So this basically shows what it is. Like I was talking about with the vent, okay, you're gonna have a radon vent that comes up from under your slab. If you have a slab, if you're in a crawl space, it's just gonna be, you'll have vapor barrier there, and then the gravel under the vapor barrier, you'll have your vent. So you're gonna have a plumbing T under your vapor barrier in the gravel. That T is just gonna be left open so that gases can get into it, and then it's gonna vent straight up vertically through the house. As you see here, you'll have a pipe that runs, just PVC pipe. It doesn't need to be labeled at each floor. So just take a Sharpie, write in big letters on it, radon, okay? Needs to be labeled at each story of the house, each floor of the house. You'll have that go straight up, and then it just vents up out through the roof, okay? Just like a typical plumbing vent. That's your passive radon system, okay? Radon is naturally in the ground in rockier soils. It's much more prevalent, apparently. I'm no scientist on it, but I did some basic research. The IRC code, and I'm not sure when they came out. Maybe it was 2018 code is the most recent not the most recent. It's the oldest version of the code that I'm really familiar with, that I've studied. I've read some stuff from the older codes, like 2016 or earlier, but 18 I know has the radon appendix in there, appendix F or H, something like that. Anyways, look for it. They actually changed it with the most recent version of the code. They moved it to a different appendix, but it's still there. It's not that long. Take a look at it. There's not a whole lot that's really required in that appendix. It more just discusses how to deal with radon, and then each local area will typically decide how they want to handle that themselves. Give me just a sec. I need to let the dog out of the room, or he's going to have to fit. Okay, sorry about that. Moving on from that. Well, let's see. Was there anything else I want to say about radon? That's pretty much it for the passive. Oh yeah, I was going to mention the active versus passive system. So that's your passive system. There's no fan in it or anything. It just passively vents, just like a plumbing vent, vents up out through the roof. Now, an active system, you can take this passive system, cut that pipe, let's say in the basement right there, right? Or even sometimes right down at the slab. You insert one of these fan things that we were looking at. Where'd they go? One of these, right? And so you'd have the vent pipe coming up into the bottom of that, and then coming out of the top. It's just got a little fan in there. You usually plug it in, so you'll need an outlet nearby. But you plug it in, and it will actively suck radon gas out from under your foundation and vent it up through the roof so that it's not getting in the house. The whole point of this, radon gas is, I guess, like the leading or one of the leading causes of, lung cancer. And this is a more recent discovery. People haven't known about this for decades, right? It's like maybe 2 decades now but it's not, this doesn't go back to the 50s, 60s, 70s and all that. That's why you won't find radon systems of any kind in older homes. But it is important. So get your radon tested. It's very simple to test. You can order a test online. I think they're like $80 or something, or just ask your local building official, building inspector. They can typically come out and test radon for you. I know I did that for my town. Basements, this is going to be a very big concern. Crawl spaces, it's a concern. If you're a slab on grade, typically nothing is really required for that. If you're like pier and beam, that's going to be similar to a crawl space. If you have a curtain wall, if you have no curtain wall, then you got tons of ventilation going under there. That's not going to be a concern. But basements especially is where your biggest concern is going to be. So make sure you have a radon system. Make sure that vent is accessible and that there's space around it to install one of these if you ever need to, or if the homeowner ever needs to. But anyway, so that's your radon system. That's going to be part of, hold on, let me bring this back over. So that's going to be part of your subslab. Trying to think of where I was. So radon. That's one of basically what I'll call the 4 components of subslab step. So you got your radon, you got your DWV. So if you have basement or a slab on grade foundation, you're going to have drain lines that run under your slab, most likely. Not always. Basements, you can do a pump or whatever you call it that ejects the sewage out so that you don't have to go under slab. That is more expensive, so keep that in mind. But anyways, I typically will just take drain lines under the slab and then out, but I do mostly walkout basements. If I can't do a walkout, I'm not a big fan of doing a basement. If I can do a walkout basement, I almost always will. I'll do like a semi above ground basement and then have it walk out on one end. Those are great. If you can't really do that, then it's usually not going to be worth it to do base. It depends on what you're doing with the property, honestly. If you just need a lot of rooms, like you're doing this as an investment and you want a lot of rooms in the house, do a basement. You can fit a lot more rooms there. You can do a main floor, and then you can even do a second story on top of that, and you can maximize the number of bedrooms that you and bathrooms that you have in that house, using it as a rental, for example, or like an Airbnb, a rent by the room situation, those sort of things, right? So that's something to keep in mind. But you're going to have DWV, your drain waste vent. These are your drain lines for plumbing. Those are going to run typically under a slab if you have a slab. So all of this, any water lines as well. I am not a fan of doing water lines under slab. There's really no reason to. So I would just avoid it. If you do have to do water lines through the slab, put them through a sleeve. Put a PVC pipe sleeve that runs down through the slab and then under the slab all the way, and then back up to wherever that water line's coming out, so that you can freely slide that PEX line or whatever you're using for your water line in and out of that sleeve if you ever need to. So you'll have that. Let me think what else. Drainage is going to be, you want to be looking at your drainage. Okay. So your engineering reports should identify any drainage issues that you have. If you're not sure, get a geotech or somebody out there to take a look at it. But basically you should know if you're going to have drainage issues or not. If you have a high water table, you're going to need some proper drainage. If you have, if you're on a slope and the water kind of if you're in kind of a drainage path on a slope, you definitely want to make sure that you have an easy way for that water to divert around your structure. Things like that. So drainage is really important. You can do a French drain on the outside. You can even do French drains on the inside of the foundation wall. I usually will just do one on the outside, and that's plenty good. But if you have a high water table and you're worried about water coming up underneath the house, then you definitely want to make sure you have some good drainage under there, a good bed of gravel that's under the slab, so that it drains down easily, those sort of things. Drainage, and then your waterproofing around the outside of a foundation. So if it's a basement foundation, you're going to have at a minimum probably some tar around the outside as your waterproofing. I like to do dimple mat on top of the tar because the tar itself is not, it's not foolproof by itself. But if you have a dimple mat there, it creates a drainage plane, a gap in between any fill dirt and then the actual concrete wall. That creates a drainage plane where water can drain down, and so it's not sitting up against the foundation. If you have dirt and mud just sitting right up against a concrete foundation, a basement foundation, even with that tar waterproofing on there, you still have water that's just sitting like a wet sponge sitting up against that foundation for who knows how long, right? Depending on where you live, it could be all year, or it could just be part of the year. But you know, that's going to create issues. Eventually that water is going to find a crack or something to get through, right? If you have that dimple mat around the whole outside of the foundation, you'll see this in my A-frame build series. We did dimple mat everywhere before we backfilled. So that helps a lot with drainage. That's what I usually will do for a minimum, and then add a French drain around the outside if I'm worried about some water coming through there. But yeah, that's the French drain. Also is typically, like I said, with a walkout basement, it just makes it easier to do a French drain if you have a slope that you can daylight that drain out to, instead of having to do a gravel pit or something under the ground there for the drain. Let me think. Sub slab. Anything else with sub slab? Oh yeah, the insulation that goes on under your slab. I mentioned before you could do a couple different things with that. You could either do 2 inches or 4 inches of foam board. If you have it in your budget, do 4 inches. That's gonna be your best. But I would do a minimum of 2 inches at least. And then make sure you tape and seal all that. You're gonna do vapor barrier on top of the foam board, so that when they pour the cement, there's no chance any of those pieces of foam board will float up in the concrete, and that'll create a huge headache for you. So vapor barrier on top of the foam board. Make sure it's taped all around all the edges, all the seams are taped, everything, and then you're gonna come in and pour your concrete on top of that after you lay all your reinforcement out, your rebar or whatever. There's fiberglass bars, rebar, whatever you're gonna use. I think we talked about that with foundation. So yeah, insulation. You can insulate basement walls. You can insulate the stem walls for a crawl space, usually with foam board or spray foam. Closed cell spray foam works good for that too. If you don't mind the off-gassing, which supposedly they have. I mean, they do. Supposedly these days they have better ways of doing it to where you don't have so much off-gassing. I'm not an expert, so I do like using spray foam in certain situations, like when I'm doing a cathedral roof ceiling, a vaulted ceiling, so I don't have an attic area up there for insulation. I'll do usually I'll do what's called a flash and bat. So I'll do a few inches of closed cell spray foam up against the roof deck, turn it into a cold roof system, do the spray foam up against the roof deck, and then just fill that the rest of it with either fiberglass bat, blown in cellulose, or rock wool is also an option, but I usually don't do that, just because at this point, if I'm doing flash and bat, then it's a cost factor. So yeah, lots of different things with that, but we'll go into that in more detail when we get to the actual installation stuff. So I think that covers it for sub slab. Let me know if you guys have any questions about any of those items. It is pretty important. You are going to get this inspected. You need to pressurize any of the plumbing that goes under the slab. So all the drain lines, you're going to pressurize. And then water lines. If you're doing any water lines there on the slab, you probably want to pressurize those before at the same time, but those can also be pressure tested when you do your plumbing inspection, your rough-in inspection. But the sub slab, I'm pretty sure in most areas the inspector is going to want to inspect that. I know in our area, I always inspect that before they pour the slab. So I'll come out, check to make sure they have the radon vent in, check to make sure they have compacted gravel, all that. Check to make sure that they have vapor barrier down. Check to make sure that they have the pressurized drain lines for the plumbing, and then just their waterproofing around the foundation. That's basically everything I would look for in a sub slab inspection. And it's not always called sub slab. There's different names for it. I just call it sub slab because that seems to incorporate most of those items all within one term. So once you have your sub slabs done, you come in, you pour your slab. That's really part of foundation, but I'll cover that in a little slab specific details. So specifically with the slab, you're looking for reinforcement. You want to make sure it's strong enough for whatever. So if it's going to be a basement slab and you're just expecting foot traffic on there, just go with probably a 3,500 or 4,000 PSI concrete mix. Do your standard rebar reinforcement. You can, in a basement, you don't necessarily have to use rebar. You can just do microfiber. You can do the microfiber mesh in the concrete mix. You also have the option of like fiberglass bar instead of rebar. There are some other options. There's tension. We don't do any of those around here. I don't do the that's more common like down in Texas, I think, where they do slab on grade. We don't do any slab on grade here in the mountains, so I'm not real familiar with what's it called, tension tie or whatever, slab foundation. But basically make sure your slab is reinforced to your liking based on what it's going to be used for. A garage slab, I would probably go with a little higher PSI concrete mix. 4,500 might be good, 4,000 minimum, I would say, even up to a 5,000 mixed if you're going to have some heavier stuff in that garage. Make sure you have good reinforcement. Tie your reinforcement into the walls, the stem walls. That means just drilling holes, sticking your rebar in there. Often you'll epoxy it in there, but a lot of times I've done garages where the engineer said it was fine not to use any epoxy, just to set it in there and pour. So yeah, get your slab in. Once your slab is in, we're on to step 5, which is your framing. If you're not doing a slab, then obviously you're skipping over that. Like if you're doing a crawl space, right? You're just going to start framing on top of that crawl space wall. The framing is, like I was saying before, this is a really big step. This is where a lot of things are going to become important. Let's pull up. I should probably use this more, huh? To show examples of what I'm talking about. Now the dog wants back in. 1 second, please. Okay, we'll see if he listens. I told him to go lay down. So framing. I think most people are more or less familiar with what house framing looks like. We see homes getting built in our neighborhoods all the time. Most of us do. So let's look at this first. This is typically what you'll see from the outside. Now this looks like a huge mess, and it's hard to, and actually this is not a great way to do house framing. I would at least have sheathing on that bottom, the bottom floor at this point before I start framing that entire top and putting roof trusses. They probably have some shear strength out. I mean, they obviously have some bracing here and there, and that's adding some shear strength. I don't like to risk it. I like to get the shear walls on, at least for the bottom floor, before I go up a story. And typically, if I can, I'll even just build the walls with sheathing on them on the ground, then lift them up. So the sheathing's already on there before they even get lifted up. But that's a whole nother thing. That's up to your carpenters. However they like to do it, let them do it that way. I am a carpenter. I like doing framing myself, so I do a lot of framing myself, just because I enjoy it. It's something. It's what I started in. It's what got me into construction, and I still like doing it. So just make sure that you're doing things in the proper steps, though. Okay, so the proper steps, what are they? You're going to start from the ground up. Okay. So you need your floor system first. If you're doing a crawl space foundation, you need to put floor joists down, right? So your floor joists are going to sit on top of what are called your plates, your bottom plates, pressure treated plates, whatever. That's what sits. It's almost always going to be pressure treated. These are going to be boards that just lay flat on top of your foundation, going all the way around. Wherever you're going to have walls, exterior walls sitting on top of that foundation, you need to have a pressure treated board sitting flat. That's called your plate. Sill plate is another term for it. And then you're going to build everything else on top of that. The reason for that pressure treated is to make sure that there's no possibility for rot to spread through the moisture of the concrete being wicked up into the wood. The pressure treatment of that sill plate will stop any moisture from getting up into any of the other wood, and the pressure treated lumber will not rot itself. I guess it does eventually, but not nearly as fast as normal lumber. So you're gonna have your sill plates go down first. Whether you're doing slab, crawl space, basement foundation, even any interior walls, you're gonna need a pressure treated sill plate down. You're gonna have sill sealer under your sill plates, so you're gonna have concrete. Let me see if I can pull that up real quick. That would be a good one. Sill sealer looks like this. So you're gonna have your concrete foundation. You're gonna have your anchor bolts sticking out, right? You're gonna go around. You're gonna lay this out flat. It unrolls. And it's just like a thin layer of dimpled foam, right? You're going to lay that out flat everywhere where you're going to put a wall. Then you're going to put your pressure treated plate down right on top of that. Let me see if it shows it with PT plate. Images. So that's a pretty good image right there. This is black, but it's the same thing as what I'm talking about. So you can see they have their pressure treated lumbered plate. Underneath that, between the concrete and the pressure treated plate, they have sill sealer. This one is black. It looks like it's plastic or something, but that blue foam stuff I was showing you, or it can be pink, lays right there. Make sure you get the same width as your plates. It's not the most important thing, but it's just good to have the same width. Now, I will also typically lay a thick bead of some sort of sealant. Acoustic sealant is good. I like just using Lexel because I always have a bunch of Lexel on hand. I'll just run a bead of Lexel on both sides of that foam strip so that it is sealed to the concrete and then also sealed to the pressure treated plate, the board. And you don't have to worry about any air gaps in there, gaps for bugs to get through, anything like that. So it just foolproof for that whole system. It's not very expensive. Lexel can get a little expensive, but you might spend, I mean, you might use what, 6-7 tubes of it. So you're spending maybe $100. Plus you have your sill sealer, the foam that you're laying out. After that, you're going to have your plate down. Sometimes you'll have a second plate that goes on top of that, just standard lumber. We did do that in our A-frame build series. If you go back and watch that, you'll notice we did a double plate for the sill plates. That was called out in the plans. You don't always have to do that. For a typical standard home, you're just going to have a single pressure treated plate, and then you'll frame your wall right on top of that. That's normal to do. That's just fine. The plans that we were doing for the A-frame required this because of the way every single joist was being anchored down with bolts. You needed to have, well, with lags, they needed to have enough meat in the plates to lag those 3-inch lags into. So we needed a double plate there. That was the reason for that. On top of your sill plate, though, like I said, you're going to have your framing. This is just going to be your stud walls most of the time. Let's go back to this. So this is going to show you your stud walls. Wherever you have windows, doors, and whatever, you're going to have special framing around that. But other than those areas, it's basically just either 16 on center, 16 inches on center for each stud, or that means the amount of space in between each, or 24-inch on center, right? Both are fairly typical. It just depends on the engineering for your specific build. So check your engineering, see what it calls out in the plans, and then build that. I will say almost always I will do 16 on center for exterior walls, just for the added strength. Even if plans say it's okay to do 24-inch, I still like having 16-inch, and that's pretty standard. What else do I want to say about it? You have different heights for these. You could have, 8-foot ceiling height, 9-foot, 10-foot, or up. Once you get over like 12 foot, you don't really want to use standard lumber anymore. So that's something to think about. Your engineered plans will specify what you can use, but typically, even if my plans don't specify, but I have a wall that's going to be more than 12 feet tall, I like to go with some sort of engineered lumber. So for me, that's almost always LVL, just because I like LVL the best out of the engineered lumbers. But you can go something like LSL, which is a little bit lower grade than LVL. It's just like OSB, but turned into a board, kind of, in my opinion. That's what it looks like, and a lot stronger than OSB. Whereas LVL is going to be laminated sheets like plywood turned into a board. Okay. I like LVL. That's what I like. I built my shop with 16-foot tall walls. I framed the entire thing. Now, a lot of people nowadays will just go with a post frame for that, like these pole barn type structures, and we do that a lot around. See a lot of that around here as well. Since I do most of my framing just traditional stick frame, I went ahead and just bought a bunch of 16-foot LVLs and framed the walls with those, and it works great. I think LSL would have worked as well for that. If I remember, I think the engineer said the LSLs would have been fine too, but I went with LVLs. They were a little bit more money, but I really like the LVLs better than LSLs. I just feel better using them. So you're going to build up your stud walls on your main floor. You're going to have headers for your windows and door openings. On any structural wall, you'll need a header that's called out by the engineer in your plans. Typical headers are going to be like a 2x8 or a 2x10 size, usually two of them together. You can do what I usually like to do are box headers. So I'll do like two 2x10s. If it's a 2x10 header, I'll do two 2x10s with some foam sandwich in between. And then you do a 2x6 laying flat across the top and the bottom. So you create a box with foam core in the middle, and that's your header. I like to do headers like that. They're just a little bit more efficient, and you get a nice nailing surface on both sides. But your header is going to be held up by some special studs that you have on each end of it, called jack studs. And then you're going to have a king stud on wrapping the outside of that. Little more advanced, but I can actually show you. Doorway framing. I should have looked up a window though, because a window would show you the cripples as well. But basically, you can see you have the jack studs that hold up a header, and then outside of the header you have king studs, sometimes just one king stud like here, sometimes more than one king stud. The whole point of this is to transfer load down to the foundation without breaking anything, essentially. So the headers keep the door from being crushed without any support above it. You can have these cripples. That's what you call these little short pieces that will either go above a header like here and here. This is not a load-bearing doorway, so that's why it's just a single 2x for the header. These are load-bearing doorways, and so that's why you have much bigger headers specified for these. It all just depends on whether your wall is load-bearing or not. We can go to window framing. And this gives you a good example of it's basically the exact same, but you have your sill along the bottom and you'll have some cripples under it. Now, a lot of people will put a cripple at each end as well. That's really just for keeping it steady. You don't need that for structural purposes. And as far as I know, that's not required by any code that I've ever built by. That's just something they used to teach it that way, building windows to have those on the outside. But from everybody I've talked to nowadays, there's really no need for that unless your window is so narrow that there's only like one stud under it. Then most people agree it's good to have at minimum 2 cripple studs underneath a windowsill. But yeah, all of these technically work. I think it's hard for me. It's very small on my screen because I'm looking at the recording. Yeah, so you can see they do it both ways here with continuous jacks or split jacks. But basically it's the same as the door. You're just adding the windowsill across the bottom and then any cripples under that. The cripples are always going to stay on your layout. That's for layout. Okay, your layout is your 16 on center or 24 on center layout. Layout is where you're going to be nailing your sheathing on the outside and your drywall on the inside too. So you want to make sure, because those sheathing always comes in 4x8 foot sheets, and drywall comes in 4x8 foot sheets or 4x10, 4x12. I mean, they can be longer, but they're always 4 feet across and then either 8, 10, 12, right, long. So that is specifically done on purpose so that you can always land your seams on a stud. When you have 2 seams of 2 different sheets of drywall or 2 different sheets of sheathing that butt up to each other, you're going to have those nailed in. So you want a stud right behind that seam to nail the edge of those sheets into. So that's why you're doing all your stud layout, either 16 on center, 24 on center. There are others. You could even do a 12-inch on center, but that's by and far the most common are 16 for exterior walls, 24 on center for interior walls. That's how I usually frame all of my houses. I think that mostly covers it for your main floor framing. You will have some beams and stuff that come through. This is a pretty big beam landing on a header right there that does not look like a very big header. Engineers will call all this out in the plans. Whatever is required as far as your header sizes, beam sizes, all that stuff. Just make sure that your framer is framing it according to what is on the plans. If it says to do it this way on the plans, he needs to frame it that way because that's what the inspector is going to be looking at. Unless your engineered plans were just not done correctly. So that would be the one exception. Moving on from there, we have, let me go back to our other image. Where was it? This one. So then you're going to have, if you have a second story, you're going to have a floor joists that land on top of that wall. So on top of the wall, you're going to have almost always a double top plate. You can do a single top plate if you stack your studs and joists and trusses. If they're all stacked right in line with each other vertically, you can get away with a single top plate, but almost everybody builds houses nowadays. Even if you are stacking your studs, joists, and trusses like that, most people still will use double top plates. That's pretty standard. Code requires it in a lot of places. So you'll have your double top plates, and they have to overlap at the corners, and that's why you do a double. The single can be used, like I said, in certain circumstances where like it's just a partition wall, and a lot of times this is done in remodels. But anyways, I digress. That's basically, you're going to have your double top plates that interlink all the walls. So anywhere where you have like a corner, you're going to have one wall, framed stud wall, one framed stud wall. They meet up. You're going to have your top plate run over on one of them, and then the other one is going to run over this way on that, so that your top plates overlap, right? That's going to link all of your corners together and make them solid. You're also going to be nailing your studs together along the whole vertical length of that corner, okay? So everything gets tied together there. You put your joists on top of that. You're going to have rim joists all the way around your joists. If you're doing crawl space, you're going to have joists for your first floor as well. So not a whole lot I want to say about joists other than just make sure they're sized appropriately. There's a few different options for joists nowadays. You can either do the traditional dimensional lumber, like a 2x12 or a 2x10 joist. Those are not the most fun to work with because boards are almost never perfectly straight, and so you're going to have some differences in there. That's why most people nowadays will use engineered materials for that. like engineered I-joists, or you can use engineered floor trusses are two really popular options nowadays. The I-joists are nice because they're lightweight, they're easy to work with, they're not very expensive, and they're extremely strong, very straight. They're easy to run plumbing and everything through for the most part. So I-joists are very popular. And then there's also, like I said, the floor truss. So a floor truss is like a roof truss, but it's made for a floor. So it's just a rectangle instead of being a roof shape. They just make it a rectangle. It's like it's the shape of a 2x12 board, let's say, right? Usually about 2 feet though, instead of a 12-inch, it'd be so double a 2x12. But it's webbed, right? It's got the different pieces that go in between. So it's just made out of 2x, just like a roof truss. It's just made out of 2x across top, 2x across the bottom, 2x at each end, and then it's got diagonal 2x's in the middle that give it the strength. Okay. So those are really easy for running mechanical and stuff through. If you have a lot of mechanical duct work that you want to run through the floor trusses, or through the floor joists, you can go with a truss system, and that gives you lots of open space where you can run that stuff right through there. So those are great for that. Like I said, they do take up a lot more space though, because you have 2 foot, typically 18-inch to 24-inch tall floor trusses, versus a floor joist like an I-joist or a dimensional lumber would just be like a 2x12, so less than 12 inches. So joist materials matter. You're gonna have a rim joist that runs along the outside at the ends of your joists, just to cover up the gaps there at the end of your joists. That's called a rim joist. So that basically you have a solid wall all the way around at the top of your foundation. Then you have your subfloor that goes down on top of that. Subfloor is typically 3/4 inch ply or OSB. You can use thicker than that. The 1.1 is pretty popular nowadays, thanks to Advantech. But it was used before Advantech was around. But 1.1 really gives you a stiff floor, especially if you have wider joist spacing, and it can allow for wider joist spacing. Like if you're using floor trusses, you don't need the spacing so close together, because those trusses are just gonna be a lot stronger than a typical joist. So you can space them further apart, but then you got a bigger gap in between joists, right? So how do you take care of any deflection that's gonna happen from that? Well, you use a thicker subfloor. So subfloor, you go from a 3/4 inch OSB, you could go up to 1.1 OSB, for example. And that's gonna give you a nice thick, stiff subfloor. On top of that subfloor, you're gonna frame your next wall, your next floor, all the stud walls for that. And you're gonna go up from there. If you're only doing one story, then obviously you're not gonna have joists. Instead of joists on top of your first story walls, you're gonna go with your trusses. This is where you'll have a bunch of trusses laying on top of the walls. Or rafters. You can go with hand cut rafters or engineered trusses. Most people nowadays could just go with trusses because they're a lot simpler and easier. You just order them. They come in a package all together. They're numbered, so you can just put them up there in order. Usually use a crane to get them up there, unless they're small enough that you can get them up there by hand, more or less. I've done that as well. I did that for my shop, actually. Yeah, what else do I want to say about that? I like using trusses. They work a lot better. You can even do, scissor trusses if you want like a vaulted ceiling on the inside. You can do attic trusses to give you a big, like a room inside of the trusses, an attic space where you can have storage and whatnot. That's very popular. They're going to cost a little bit more, but gaining that storage square footage a lot of times is worth it. So yeah, that's the basics of framing, I think. You're just getting the skeleton of the structure put up, right? This is what you're going to be attaching all of your sheathing to, and then on the inside what you're going to be attaching any of your finished material to, usually drywall. So make sure your framing looks good. You're going to attach your hold downs and all that, like I talked about with the foundation section last week. Trying to think if there's anything else I wanted to cover as far as framing. I think I covered materials. So you can have dimensional lumber, you can have T-studs, which are kind of like little engineered studs. Look those up if you're interested. They're more expensive. You can use the engineered lumber, like I said. Instead of just going with standard lumber, you can use LVLs, LSLs, that sort of stuff. There are steel studs as well. You can always build with steel instead of wood if you would like to. In wildfire prone areas, this might be a good idea, although there are ways to fireproof your home and still use lumber to build it. I don't know. Some guys like steel. I like lumber. I'm a carpenter, so I build with lumber. That's how I do it. So we talked about dimensional lumber, engineered lumber, LVL, LSL, OSB is also an engineered lumber. Trusses, I-joist. So let's move on to our sheathing. This is your sheet goods. So your sheathing is going to wrap the entire outside of the structure more or less to protect it from the elements, give it structural strength, shear strength, all that sort of stuff. There are places, I guess, down in Texas and whatnot nowadays, they're sheathing houses with cardboard. And then they just use cut in or let in 2x bracing for shear strength. I would just go with OSB sheathing. You know, if it was me and I was trying to save a little bit of money, I would never feel good about sheathing a house with cardboard, right? Just covering the house with cardboard and calling it good, putting siding on top of that. I would not feel good about that. So to each their own. We definitely don't do things like that around here. So typically it's going to be your 7/16 OSB. That's the most common material for your exterior sheathing. You could go thicker if you want, but that's really good enough for most cases, unless you're in like a hurricane zone or something. They may want something thicker. I don't build in a hurricane zone, so I'm not sure. But yeah, it's OSB is the most common. You can do plywood if you want. Zip sheathing is very common nowadays. That's an OSB sheathing that they put a waterproofing membrane on the exterior of. It's almost always green. I think there's yellow as well for a different kind of sheathing. But yeah, the green 7/16 zip sheathing, I like using that. Nowadays, a lot of times you can get it for almost the same price as just regular OSB. Especially if you're using like rebates and stuff like that, you can actually even get it cheaper than regular OSB. So zip sheathing, something really helpful if you're doing, you know, your house wrap yourself, you're not experienced. It's a lot easier to just tape the seams on sheathing than to try and hang 9-foot rolls of house wrap all around the house, in my opinion. Now, if you got a crew of guys working on it, I don't know, that may not be the case, but I like having the zip sheathing. I think it simplifies the process. So I'm not opposed to using that by any means. But if you're trying to save money and you can get OSB a little bit cheaper than zip, OSB works just as well. You don't need to tape the seams with OSB. You're going to put your house wrap around the OSB, right? It's like a paper product, 9-foot long rolls, like 9 foot long, and then they're usually 150 feet or whatever per roll. So you're going to cover the whole house with that. Let's see if I can show you an example. And then you'll tape the seams and everything with the house wrap around it to make it all airtight, basically, or vapor tight. Let's just look up house wrap. Something like that. Nope, that went to the shopping thing. Whoops. House wrap on house. I guess I could have just gone to images. So yeah, there you go. There are different colors. The kind that I usually use nowadays is the blue one. Not that blue one, but anyways, the blue is just a little bit more durable, I find, than just the simple white paper kind. But if you're covering it up real quick with, that's a really dark, that's like a peel and stick. Yeah, but here's pretty typical house wrap on a brand new construction, right? So they put their sheathing up on the walls and then they put this house wrap up. You can tell the walls are a little over 9 feet tall, it looks like, if that is a 9-foot roll. But yeah, so you just wrap it all around the house, then you'll cut out around your doors and windows. Very simple. You're going to go around and tape any seams that you have. I always tape along top, bottom, everywhere. Get it sealed up nice and tight. With zip sheathing, that's not necessarily needed. So I'll show you zip sheathing is like this. So you're just using this black zip tape, which is an amazing tape. I use zip tape for a lot of different stuff, not just for sheathing like this. But basically, you can also do the roof with the sheathing. It's this is their 5/8. Roofs you're usually going to sheathe with 5/8, whereas the walls are 7/16 or ½ inch basically. So you have ½ inch on the walls, 5/8 inch on the roof, and then you're going to have 3/4 inch subfloor, your sheeting for your subfloor inside. With the zip system, you're going to tape all the seams and everything. You can see that in my build series videos as well. Steeper roofs are going to be harder to work on. The steeper it is, the more costly it is to work on. That's just how it goes. If it's a nice low roof pitch, like a 412, 512 pitch, super easy to work on. I can work on those all day long, no worries. Once you get over like a 12-12 pitch, it gets real, a 45-degree angle. It gets pretty tough. Even up to that, from like a 6-12 up, it's going to require a lot more time and just being more careful, equipment and things like that. So zip sheathing, really good for doing a sheathing system. Zip also makes a zip R sheathing. This is sheathing, OSB sheathing, just like the green stuff you're seeing here, but it has a layer of foam on the inside. So you can get like 1/2 inch, 1 inch. I think it even goes up to like 2 inch. I would typically do a 1 inch foam on the inside. So that's, what is that? An R6, right? I think it's an R6 zip sheathing. That is still structurally safe for your shear walls, if as long as it's installed correctly. So you don't have to worry about that. A lot of people worry about kind of the strength you're getting if you have a layer of foam in between your sheathing and your studs. They've done experiments with it. Huber, who makes zip sheathing, has put out literature on this. It's fine. According to them, it's fine. Shear values are maintained as long as it's installed correctly with the correct fasteners. So something to keep in mind there. You also have, like we saw before, a peeling. Oh, here's an example of that. I don't know if you guys can see that, but there's some foam on the underside of each one of those sheets. So that's your zip R sheathing. The house wrap, well, that's all going to be in the drying, so we'll talk about that more with the dry and the house wrap stuff. There's not a whole lot to that, but I'll talk about like peel and stick with that. That's another option that you have. Anything else with framing, you got your sheet goods, hardware, nails, screws. You're going to need all of it. Lots of different sizes, nails and screws. I usually have buckets of, everything from a 2-inch screw up to a 4.5-inch screw. Like deck screws, just use regular. I use deck screws for everything. Even on interior work, even though it's not necessary, technically you could just use waterproof screws there. I use deck screws for everything because it's easier for me to just buy buckets of those than having to have 16 different types of screws, right? Nails, you're going to have your strip nails for your nail guns. You're going to need, you're going to have different sizes. So you're going to have like 2 3/8 for your sheathing. Then you're going to have 3-inch for interior framing. You have like 3.25 or 3.5-inch for your exterior framing. You're going to need just bright smooth nails is fine for interior. And then you're going to need your coated nails for exterior work. So that they're waterproof. Anything going into, sorry, not exterior work, but any nails going into pressure treated is where you need the coated nails. Or galvanized, galvies. We just call them galvies. Not coated, but galvanized nails go into pressure treated. Everywhere else, you're okay to use just the smooth coated nails. You're going to use ring shank nails for things like sheathing. So you'll have like the 2 3/8-inch nails, ring shank. Use those for sheathing. Galvies are good for that too, but they're really expensive. So I usually just use the galvies wherever you have pressure treated that you're attaching to. Hardware, you also have all your fasteners like your joist hangers. You're going to have hurricane clips that attach your trusses to the wall, your roof trusses to the wall. You're going to have joist hangers that your floor joists, any of your joists that you have are going to hang in and then attach to the rim joist with that or a girder. Yeah, hardware, that's pretty much it for you. You'll have like metal strap and stuff that goes in different places based on what the engineer calls out. Your engineer set of plans will call out anywhere where you need hardware. Just make sure you have all the proper hardware where it goes for that. Adhesives, there's adhesives as well. Like when you're doing subfloor, make sure you're gluing your subfloors down. Don't just nail them. I would never just nail subfloors or even just nail and use adhesive. So you can use the subfloor glue, then you nail it down, and then I like to go back and put a few screws into each sheet. Usually near each corner of the sheet, and then one somewhere around the middle. That just holds the whole sheet down even better and ensures that none of those nails ever come loose and squeak. What else about that? Yeah, just make sure you're using adhesive there, like stair treads. I like to use adhesive there so you don't get squeaky stairs, things like that. There's a few other places you might use some adhesive, but Uh, that's really the important ones. Equipment. When you're framing, you're gonna need some equipment. Okay, equipment's gonna be expensive. That's either your builder, or I'm sorry, your framer owns their own equipment and then they're going to charge you for that, or you're going to have to rent equipment for your framer to use. I typically, since I am the framer, usually I don't own my own equipment. I will usually just rent. I'm planning to buy some of my own equipment, but I do not buy things on loan. So I save up the cash and then I buy them. I'm saving up the cash to buy some equipment, and when I do, and I feel like it's worth it and I find a good deal, then I'll buy some. Until then, I just rent and it works fine. The equipment that you're going to need. Telehandler, at least for us around here, is probably the most common piece of equipment, the most useful piece of equipment you're going to have on a job site during framing. I mean, it's pretty straightforward. It's an off-road forklift. Okay. But not only that, it's a forklift that can reach really far away. So this is just an immensely handy piece of equipment. This is probably the first thing I would buy as a builder. Before getting anything you need for excavation work, I wouldn't, the excavator is tempting because excavators are very useful as well for a lot of different stuff. But honestly, if you're looking for the top piece of equipment for a job site, this is probably it, I would say. So whatever your first thing is, this is what I'm saving up to buy first, for me personally. And they're not cheap. They're one of the more expensive pieces of equipment that you're going to have, but they are well worth it. These things will increase productivity immensely. Yeah, not much else I can say about that. They're great to have. Make sure you have one. As far as rental rates go, it's really going to depend on your specific area, but typically your rates for something like this are going to run, I'll say $500 a day, probably around $1,500 for a week, and then a month is going to run you like $2,000, $2,500, something like that, right? Did I do all that? Yeah. Anyways, I think I said all that right. Yeah, $1,200 a week. Yeah, that's probably about right. The more the more often you rent from a place, they're going to start giving you deals and discounts and stuff because they know you and they want you to keep coming back, especially if you have if there's competition in the area for rental places. In my area, there's really only a couple places you can rent from, so there's not a lot of options, and a lot of times you're just going to have to go with whoever has that piece of equipment available at that time. Another piece of equipment that's going to be very helpful for framing is going to be your boom lift. Cherry picker, some people call this, lots of different things. But basically this is something that's going to allow you to lift, I went to this stupid thing again. To lift guys up in a basket to do work high, excuse me, to do work high up. That's a good example of one that I would typically use. I think if you watch, actually that's the exact one that we used on the build we did this year, the A-frame build that you'll see in the build series. Actually the one we were using was a little bigger. I think we were using a 65, that's a 45. So it's a little bit smaller than the one we were using. But the height of your building will typically determine and what you need. So for example, if you're installing really big windows really up high on a wall or something, big windows for a great room or whatever, this is going to come in handy for stuff like that. You'll see on the A-frame that we did, we actually used this for sheeting the roof, as well as taping the roof and all that. So a lot of the stuff that had to do with the roof, once we had the roof framed up, we used one of these. So that's called a boom lift. And then you're also going to have a crane, and I didn't really mention for the telehandler and the boom lift cost about the same to rent. Those prices that I mentioned before, like $500 a day, $1,200 to $1,500 for a week, and then usually $2,000 to $3,000 for a month. Now, a lot of times, like I said, if you're doing roof trusses, let me come down here and not click one of those things again. Where's just a simple little crane? Like, there we go. So when you're building a house and you need to fly trusses, it's called flying trusses. When you hire a crane operator to come out, he'll come out with his crane. He'll usually charge you, around here it's like $1,000 a day. Okay. If you need them for 2 days, it'll be $2,000 basically. Usually we can shoot to get most on a typical size home. You can get all your trusses up with a crane in one day, and that's why it's worth it to do it that way. There are other ways to get trusses up. This is the fastest and probably typically the most efficient, cost efficient way of doing it. You'll have a couple of your framers standing up on the walls of the home, and then you'll have your crane operator. You'll have a guy down on the ground strapping up each truss onto the crane. The crane operator will lift it up onto the house. You'll have your two carpenters that are up on the walls. They'll guide that truss into place. They'll nail it in place with their nail guns, detach the crane. The crane operator brings the crane back down. The guy on the ground puts another truss on. They lift it, and you just rinse and repeat, right? So you spend all day doing that. You can get usually an entire, like 1600 square foot home floor plan. You can get trusses done on a home that size in one day pretty easily, as long as your crew knows what they're doing. So that's another cost you're going to have to plan on. A lot of the times, this one actually has a cab crane. It's a cab operated crane. A lot of times the cranes we have around here now are remote operated. But yeah, pretty standard stuff. I mean, you can find these guys just about anywhere to hire to come out and for a day and lift trusses up. What other equipment do we have? You can do, like I said, there are other options if you have a simpler, like you're just in little 8-foot high walls. Let me see if is that what it's called? Yeah, material lift. I've used things like this before. These work fine too. You can actually even lift smaller trusses up to the roof with one of these. They just extend all the way up. You can get different ones that go different heights. I've used this for lifting beams up into place, things like that. So that's also an option. This, you can rent one of these for like $50 a day or something, right? It's very cost effective. As long as you're not doing any super heavy lifting, usually a crew of guys can use one of these to get a job done. Especially if you're in tight spaces, you can't get a lift in there or whatever. One of these might help. You just hand crank it. They do make electric ones as well. I'll usually just use a hand crank one because they work fine. But yeah, that's another option there. A couple other things you might have are generators, compressors, things like that, equipment that you might need. I mean, you're gonna need a compressor for sure. Well, most likely. A lot of carpenters nowadays do have battery powered guns and stuff as well. But it's still most likely you're going to need a compressor. Now, whoever you're hiring, your subcontractor, your framer, will have their own compressors, generators, those sort of things, most likely. But they will love you if you have your own already on site for them and they don't have to put wear and tear on theirs. I just find that's a nice little thing that they appreciate because they don't have to use their own equipment. They don't have to haul it back and forth, worry about somebody stealing it, whatever. They use your equipment. You're covering them. Makes everybody happy. But they will always have their own. Almost always, every crew is going to have their own compressors, their own generators for when they need them. Okay, I got to let the dog in again. 1 second. Okay, sorry about that. Again, he can't make up his mind in or out. Yeah, so I think that pretty much covers it for framing. The only other component to the framing that we haven't really talked, so we talked about materials and equipment, is the labor. You got to have your subcontractors, your labor for the build. Just make sure they know what they're doing, look at what they're doing. Costs are going to vary based on where you are. You can compare costs, but don't always go with the cheapest because a lot of times the cheapest guy just doesn't know what he's doing. That's why he gave you such a low bid. You're going to be paying for it in the end. That's all I can really say. With something like labor, unless you're just getting ripped off, you typically will get what you pay for. Okay, if you want everything to run smoothly, good quality, then you're going to be paying more for it. If you want something done cheap and fast, you're going to run into problems. That's just how it goes when you're building a house. Trying to go cheap is not always the best way to build a house. That's why people that are on a tight budget, I will usually recommend don't go and build, especially if you're building it for yourself. If you're building it as an investment and you're able to go into it with that investment mindset and really make good decisions, not just, a lot of people think because it's an investment, we have to go cheap, right? That's not the case. Don't go cheap just because you're trying to make money out of it. and especially if you're building this house for you, your family to live in, whatever, I would highly recommend go with good quality, right? It's just going to end up costing you less in the long run. Less things are going to need to be fixed over time. You're going to have less problems. If you have poor framing, then you'll end up with cracks in your drywall at some point, which is going to need to come get repaired. And it'll probably keep happening over and over again. So you're going to continually be having that repaired. So having good quality craftsmanship in your framing does matter to a degree. A lot more when you're doing custom homes. I will say it does matter a lot when you're doing investments too, though, just because of what I was saying. So labor, that's really your third component, framing. Once you get your framing done, you have the house all framed up and sheathed, you're going to move on to your dry-in phase, right? And we talked about this a little bit before. Well, let's talk about the sheathing a little bit more, because this really is the next step that I have was step 6, your sheathing. The sheathing, like I said, typically is going to be the OSB or plywood. That's providing your shear strength so the house doesn't just rack and fall over. Let me see what comes up with this. Framed house falling. So this is you may have seen this picture. I've seen this picture a lot floating around online. But anyways, you can see something is clearly wrong there, right? The house has buckled and shifted. The upper floor has shifted over, and so the bottom floor is just kind of leaning now under that weight. It's probably going to collapse. What if I put no shear walls, house collapse? No, let's do oops. Yeah, something like that. That looks like that's happening in a storm, but that's because they didn't have their shear strength. There's probably high wind in this storm happening right now or something. And this house just buckled because they hadn't put any sheathing on the walls yet and it didn't have enough shear strength to keep the walls from just buckling like that under the weight. So yeah, very important to have sheathing on your structures. Make sure you have proper nailing pattern. Your plans will dictate what your nailing pattern is. The engineer will call that out on the plans. Typically you're going to see something like probably about a foot apart for all the nails in the middle of of each sheet, and then any nails around the edges of the sheet will be typically around 6 inches apart. That's pretty standard, at least in our area. It will depend on your specific design criteria in your area, though. By that I mean your seismic design standards, your wind design standards, and snow load, things like that. So that's what your engineer is for. They'll determine all that stuff and put it on the plans. Interesting stuff, though. Make sure you have proper shear strength. So dry-in, moving on to the dry-in phase. This is step 7. With your dry-in, like I was mentioning before, you're gonna have your WRB, that's your weather resistant barrier. That's your house wrap in most cases, or if you're using zip sheathing, then that's just gonna be your exterior of your zip sheathing once it's all taped. That gives you your complete WRB, weather resistant barrier. You're also gonna have flashings on any windows and door openings. Window flashing. Oh, I didn't spell window correctly. Anyways, they still got it. So that's it. That's pretty standard flashing there. Nowadays we use a stretch tape in the corners, so you don't have to do that little corner deal. You just stretch the tape into the corner. But yeah, usually we tape all around the entire thing because we're going for a nice airtight construction to modern code. You're going to want, at a minimum though, this sill flashing at the bottom. Older construction, you won't see any tape around the top or the sides, but you will want about 8 inches up each side, and then the whole sill taped. That's your standard flashing for a sill, windowsill. Then you're going to put your windows in. You're also going to want to have your flashing over the top of the window once the window is in to divert any water from getting back there. That wasn't very common until more recently, and I can tell you, even on my house that I live in, it's an older home. There's been water. I remodeled it, so the whole thing's been fixed, but there was water getting in at one of the windows from the outside because water was just coming in behind the sheathing or behind the siding there and getting in because there was no flashing. above the window like that. So that's something to pay attention to. Door flashing is very similar. You just tape all around the opening. When you tape these openings for windows, doors, whatever, anything that you're taping on the exterior of the home, make sure that it is shingle style. And by that I mean any layers that are above bottom lower layers is going to overlap on top of it. So you always lay the tape out on the bottom first, and then the upper pieces, and then the very top piece goes up so that it overlaps in a way that water is always shedding onto the lower one and not getting stopped. Let me maybe I can find a good diagram. That was probably not the right term for that. Flashing tape overlap. Do any of these really show what I'm trying to say? I guess this kind of does. You can see it started at the bottom. They put the first piece at the bottom first, and then the next piece so that it overlapped that one, and then the next piece so it overlapped that one. So water will just continuously shed onto the next one below. If you did that in reverse, you'd have a seam that is exposed that the water is pushing against, and it could flow into that seam. This way, it's going to flow off of the seam onto the next lower piece. You're going to do that even when you're flashing around windows. You're going to do the lower part first, then the sides, and then you do the piece across the top last so that it all overlaps with that shingle style so that it sheds water downward. That's what I mean by that. That's very important. You have to do that by code just about everywhere. So make sure you're doing that correctly. Let's see. What else? We have for WRB flashing roof underlayment. So if you're doing a shingle roof, you're going to have underlayment. Let's just do underlay. Basically, it's going to look like this. So you're going to have your ice and water shield that's going to go on any of your eaves. And then in any valleys like this guy right here is doing, he's in a valley where two roofs meet and then go, it will push any water downward. So you're gonna have a high flow of water right here in this valley. That's why you put ice and water shield there, so that in the winter, if that water that's dripping down from off your roof freezes and creates an ice dam there, you have some extra protection from leaks. That's the purpose of ice and water shield. Then you're gonna have just typical roof underlayment for shingle roofs. If you're doing metal roof, which I typically do, you don't need to really have any underlayment. Technically, unless your manufacturer specifies some. Usually the manufacturers I use don't. But I still prefer to cover an entire roof in ice and water shield. This like Grace ice and water. I'll just cover the whole roof with that, and it basically makes a roof bulletproof. Trying to see if I see any examples of that here. I don't. If you're in a warmer area, especially areas where you don't have snow, obviously that's not going to be a big concern, or where you don't have freezing temperatures very often. So it's probably not necessary, but it is a really nice barrier to have against leaks from rain as well. Although metal roofs very rarely leak unless they're exposed fastener, but I never use exposed fastener metal. I always do standing seam. Standing seam metal roof is fairly bulletproof if it's installed correctly. The only places I've ever really seen leaks on standing seam metal is anywhere where you have trim pieces or flashing or whatever that had to go in, and you have different sections of roof, meaning like in a valley or something. If it's not all installed correctly, that's usually where you get the leak. Otherwise, they are pretty bulletproof. These are examples of like a cold roof system, which I mentioned before. We'll talk more about that another time, though, because that's not really important to today's conversation. But you can just see various examples of roof underlayment. There's lots of different kinds of roof underlayment. But nowadays you really don't see the tar paper too much anymore these days. Usually it's synthetic underlayment. What else do we have? Windows. Your windows are going to go in for dry in phase. You're going to want to make sure that you're stopping any rain, snow, wind, anything getting into the house, right? So that means windows, doors, all that needs to go on as well to get it dried in. Just make sure with windows that they're being installed correctly. Usually use silicone around the sides and the top of the window. Leave the bottom open. No silicone at the bottom so that water can drain out if it does happen to get in there. You'll have spray foam on the back side. Inside on that, around that window. What else? Nails, screws are both fine. If you're gonna use screws, make sure they're nice flat headed screws so that you don't have anything sticking out when you go back and tape over the edges of the window later. In fact, let me see if I can pull up an example of that. But I usually will just use nails. I'll hold a piece of cardboard or something up and then hit it with the hammer to protect the side of the window as I'm hammering the nails in. Window, man, I cannot spell today. Window install. I kind of want just a picture, like a photo. Yeah, that doesn't really show very well. Well, yeah, I don't know that you can really see it in any of these. You can see this one. Well, I'm trying to find a picture where I can show you the flanges. So these windows, when you install them on new construction, unless you're getting like European windows or something fancy, they're typically going to have a flange around the outside of the window. Actually, let's go. Flanges. There's a good example. Okay, so this is what it actually looks like. So you have these flanges, you put nails through the holes. They're going to have holes just like this. Every so often, I just do a nail in every single hole, or a screw if you're going to use screws. I have used screws before, that's fine. But anyways, so you're going to put a nail. It's going to go down the sides, the top, and the bottom. Get all that in there. This is actually showing flashing, it looks like, or building a window. But you can see on this one, they put a nail in each hole. Then over top of that, you're going to tape it all the way around except for the bottom, again, because you want to leave a drainage at the bottom of the window. So you'll tape the sides and top. Your house wrap, if you're using a house wrap, usually you'll overlap that over the top flange and then tape that down. And that's pretty much it for window install. It's pretty simple, but that's going to give you a nice dried in window right there. I think that's pretty much it. After you're done with this phase, you're pretty much ready for a blower door test if you want to. If you want to do a rough-in blower door test, that's where you're just going to basically seal up the whole house. So you're going to close all the windows. You're going to cover any vents that are already put in or whatever. And then they're going to cover the front door with this big like canvas thing with a fan tube in it. And then they're going to pump a bunch of air into the house to pressurize the house essentially with a very low pressure. And then they're going to see how quickly that pressure leaks. So that's your blower door test. That tells you how much the house actually leaks air from the framing. Some areas do that, some areas don't. If you're on more current versions of the code, you'll be probably required to get that done nowadays. But a lot of other areas, if you're like in a rural area or, you know, not a big city or something, somewhere where you're still on older versions of the code and your town doesn't really care about those sort of things. Our town does not require blower door tests as an example, but we are in a non-typical area. So pretty standard. You can see here more examples of the nailing flanges. Yeah, so blower door test. I'll just show you a quick picture of what that looks like. Yeah, there you go. It's a big red thing, goes over the front door with a fan on it, blows air in. They measure it, yada yada. Gives you a number. If you're going for like passive house or something, this is really important. Otherwise, just make sure you meet code. Whatever code requires in your area. That, I think, pretty much covers it for our dry-in. Yeah, I can't really think of anything else I wanted to say about that. So, with that said, it looks like we're kind of coming up on an hour and a half already into the stream. I try to keep these at about an hour to an hour and a half. So I think we're going to leave it there. We got through to step 7, dry in. So next time we'll pick up on step 8, roof. Well, I kind of mentioned roofing as well. So let's cover that real quick. I got a few minutes here. Roofing, like I said, you got a few different options in materials. This is really going to be your biggest decision with roofing, aside from the design of your roof, how complex it is, what the pitch of the roof is, all that kind of stuff. Beyond the design of the roof itself, which is very important. I already mentioned how steeper roofs are more expensive, right? They're just more expensive, not just for because they're going to have bigger surface area, which means more material, but it also means more labor. That labor is going to be slower because they have to be more careful. They have to use lifts or whatever to work on a steep pitch roof. So that does matter. If you have a lot of hips and valleys, it's going to be a lot more expensive. So the best thing you can do is just use very simple gable roof with almost no hips or valleys. Well, no hips if it's a simple gable roof, with very few valleys. A 412, 512 roof pitch works great. 612 is okay too, but a 412, 512, if you're doing a metal roof, those just work great in almost all scenarios. So that's usually what I will try to do if I can, but I'll do a 6 to an 812 pitch as well, especially if I'm trying to use like attic trusses and get some storage space up in the attic. What else do it? So as far as your materials go, I mentioned already that you have like shingles. You can do a shingle roof. You could do a tile roof in some parts of the country. That's popular, although it is expensive. Metal roof, also expensive, but it lasts a really long time, low maintenance. Really an all-around great option is a metal roof. It holds value really well as well. So yeah, I like to do metal on all mine. If you're gonna do metal roof, you do have different options. There's different types of metal that you can do. Typically I just go, there's different gauges as well. I would just go with like a standard 24 gauge roof is pretty good for like standing seam metal, which is what I would usually do. You can go 26 as well. That also works. There's just a few, like if you're doing a cold roof system, your what do you call them? All the boards that you're putting underneath, they need to be spaced closer together for a 26 gauge versus like a 24 or 22 gauge. Things like that. You're gonna have your trim, metal trim pieces with all that as well. Then you have your exposed fastener metal. This was more popular in the past, not so much these days, because there are problems with leaks on exposed fastener roofs when those fasteners are not installed correctly, or just over time they can become stripped. Like in a snow area, I know my roof still has, I'm replacing the roof on my house, but we bought it with the exposed fastener metal roof. We're putting standing seam on it, but a lot of the fasteners had been ripped out by ice. Ice would form on the roof. It would pull those out, those screws, some of those screws. It would somehow form around the screw and then pull it out eventually, or pull it out partially or whatnot. And I went up there and tried to put the screws back in, and they're just stripped. So things like that. I don't like exposed fastener metal for roofs. If you're doing something like, it's popular nowadays for like siding, if you're trying to go for like that barn dominium look or something. I don't like using metal for siding that much, but you can. And it's exposed fastener is fine in that case. But for a roof, I highly, highly recommend, if you're going to do metal roof, which I also recommend, but if you're going to do metal, do standing seam. It looks really good. It's going to be durable, last a long time, low maintenance, all that stuff. What else is there for roofs? I don't know. Let me know if you guys have questions about a specific type of roof. I think that I mean, really nowadays you have two options for the most part in most areas. It's going to be either shingles, composite, or it's going to be metal, standing seam or exposed fastener. Those are pretty much the most common options. 95% of the time, that's what you're going to see on a house. I like metal. It's more expensive, but it holds value better. It'll improve the value of the home, makes it look nicer, lasts longer. Lots of benefits to metal. You just have to pay more for it up front. But yeah, that'll pretty much cover it. So with that all said, I think that's a really good place to stop for today's stream. We got through, what was that, 1, 2, 3, 4, 5 more sections or steps to the home building process. We talked about subslab, we talked about framing, we talked about sheathing, we talked about drying, and we talked about roof. Each one of those is going to have an inspection, except for roof. Most areas don't come out and inspect a roof once the roof is finished. They just the inspector wants to see it before the roofing material goes on. They need to see what's under that roofing. But everything else, you're going to have an inspection at the end of that. Next Sunday, we'll have another stream. We'll pick up with the rough-ins. So we're going to talk about our mechanical rough-in, plumbing rough-in, and electrical rough-ins. After that, we go on to the insulation and drywall. I think next week we'll get through each of those steps. And then, like I was saying at the very beginning of tonight's stream, I think we'll do the finish phase as one whole stream in and of itself, probably, because there is a lot of stuff that we can talk about in there, since it's kind of a catch-all for everything that comes after drywall up to the point where the home is finished. Lots of different trades involved there, lots of different choices to be made there, and that's really when the whole home comes together. And you're typically not going to have really any more inspections after drywall until the house is completely done and you're doing your final inspection. So everything that you're doing after drywall until the final inspection, that's why I kind of include that all as just one step, as the finish step, because you're just going for the finish line at that point. It's tempting to think you're almost done when the drywall gets finished, but you're really not. You're like, at best, you're 3/4 of the way done, but probably closer to 2/3 of the way done once your drywall is up. There's still a lot of work to be done at that point to get to the finish line, but it's in sight. The house really is starting to look like a house. You're getting flooring put in, you're painting walls, getting cabinets put in, countertops, all this kind of stuff. So that's a big one. We'll probably cover all of that. Not next week's stream, but the week after that. We'll do that in the live stream. And then we'll be done talking about the entire home building process, each step of the process along the way. And we'll move on to something else. I have some other topics that I want to cover in some live streams, but I'm always open to see what you guys. I think somebody was asking about or saying that they were interested in how to find good subcontractors. We'll do a live stream on that at some point, and I'll discuss kind of my methods and what I do to find good subcontractors, especially when I was starting out, didn't know a lot of people. We could talk about ideas for that. I would love to get ideas from you guys, hear what you guys do to find good subcontractors. If you're a builder, if you have experience with this, the more suggestions we can get from the community, the more it's going to help everybody. So anyways, I'll do something on that at some point, and then we got a couple other topics we can cover. So I hope you guys are finding these helpful. Like I said, I'm going to be making some more polished videos over this same information at some point, but for now it's a lot easier for me to just get that information out there via live stream, and that way I can take questions as well if there are any questions. With that said, I see that there are a few people at least in the stream. Do you guys have any questions about anything that you want to know about or discuss that has to do with the home building process or really anything else? I've got a couple minutes left here, so let me know. Leave questions in the comments, and I can get back to you there as well. But hopefully you guys are finding this helpful. I'm doing this for anybody that's just kind of starting out, because I do get questions a lot. I comment on some videos on YouTube and stuff, and people ask me a lot kind of how this whole process works, how to make money doing it, what are some key things that you need to watch out for, things like that, right? For anybody just getting started. So that's kind of the goal with starting this YouTube channel, not just to show my builds, showcase my build series, but to also provide information for people that are trying to do this for themselves, trying to start a business, or maybe just build their own house. Honestly, it's a great learning to self GC a home build is a great use of your time, even just as a homeowner, somebody who wants to build their own home and save some money doing it. You can save probably a good 15 to 20% off the cost of a brand new home by GCing it yourself. And all you really need in order to GC a build is a few things. One, knowledge of the process, which is what we're covering here. Two, you need relationships with subcontractors, people that actually do the work, right? And three, you just need time dedicated to it. And it's not even that big of a time commitment. Once you've done the initial studying, learning the process and all that, during the process of actually building, a GC's work can be done kind of on the side, right? In the evenings, you can stop by a job site, even just once a week, to see how progress is going. You don't need to be there every day. So you could work a normal job and then be GCing a home build for you and your family on the side. Maybe with a little bit of help from somebody that knows what they're doing. But if you study all this, you do what I'm telling you, you follow the process, the code, read the code book like I suggested in a previous live stream, you know, if you do the right things, you can easily do this for yourself, and you could save 150 grand on the cost of a brand new house for you and your family. So it's not just for investors or people looking to start a business in this. That's what I'm saying. Anyways, guys, we're going to leave it there. Thanks for watching.